Okay, well, welcome to the call, everybody. 7 p.m. Pacific time. This is September 12th, 2016, and we have Paul Babcock on the call here tonight. What I'm going to do is I'm going to go ahead and mute everybody out here, and then I'll give instructions on how to raise your hand on the call if you want to ask a question. Okay, can you hear me okay, Paul?
Yeah, I can hear you fine.
Okay.
It's a little weak, but pretty good.
Okay. Let's see. So today is September 12th, and we have Paul Babcock on the line tonight. And as many of you know, he's been at the last, pretty much all 5 conferences, and most of his presentations were titled Magnetic Energy Secrets, Part 1, 2, and 3. And then 2 years ago, he did a presentation with a co-presentation with Jim Murray, The Secrets of Tesla's Power Amplification, which kind of went into some of the concepts on the SERPS technology, which Jim Murray was working on pretty much, I think, since about the 70s. And Paul's his proprietary switching technology was able to take that to the next level. And that's, they actually did a demo at the conference about 2 years ago where there was about a little over 1 watt net draw from the transformer, but it was lighting about 50 watts of bulbs. And there's some similar demos with the SERPs online, and some of the demos at Jim's labs. And Paul's been working with Jim for the last several years, collaborating on some projects. And this past July 8, 9, and 10, about 2 months ago, Paul's presentation was the simple name for it is the Babcock DC motor, but it's the external field interaction motor, which is based on the his motor prototype, which him and his partners built in order to kind of prove out their switching technology. And then it went into commercial production as far as the switching mechanism goes in some lighting control systems, which is kind of what his main product is at his company. And so we're going to be opening up for questions. And I just want to mention that Paul does have a new personal website. It's still under I guess you can say it's under construction. He's going to be adding more content as time allows. We're just kind of getting it all kind of worked out and stuff, and Paul will be adding regular updates and that kind of stuff to it. And so the domain name, if you're interested in checking out Paul's personal website, is paulmariobabcock.com, all one word, paulmariobabcock.com. And before we open up for questions, do you have any announcements or anything that you want to say, Paul?
Keep on going. All is good. I'll just catch up with the people as they ask the questions.
Okay. And so for those of you just joining us, we have Paul on the line right now. We're just getting started. And if anybody wants to answer or ask a question, all you have to do is, I believe it's, let's see, if you hit 5*, what that will do is put a little flag next to your phone number, and that'll let me know that you want to be unmuted to ask a question. So if you want to ask Paul anything about any of the magnetic energy secret presentations, or the Babcock DC motor presentation, or even the one he co-presented with Jim Murray, just hit 5*. I'll unmute you, and we can just kind of go from there. And it's about 7:04 right now, and so hopefully we can limit this call to maybe, wrapping it up around 8 o'clock or so. And so if anybody has a question, go ahead and hit 5*.
Excuse me. Yeah, Harry Mitchell here, New Zealand. And I'm just wondering if Paul is in a position to license his technology, or if he's doing that or considering doing that.
Well, we have a host of different technologies, but most of the stuff that we're doing with zero back EMF, we're not ready to license, but we're getting there. So it's
because I have a little project that friend Murray Prattley came up with this idea about 20-odd years ago and patented the concept of what it was to do, but he's never been able to make it work effectively. And I see your motor as being the thing that's going to make this thing go. effectively what we were trying to do is build a little motor inside a wheel about the size of a wheelbarrow wheel, and wanting about 40 Newton meters torque. Whether that would be possible, I have no idea.
Well, there's a lot of ways to go about it. There's, the motor we built, our field-coupled motor, or space-coupled motor, is that, like I say, it's the first one ever built, and we're right in the process of gearing up to explore that technology further. To come up with a product like that right now, I think that's a little, maybe in a year or two when we're further down the road, because we're just not into the commercial stage yet. But that's where we're focused at, is getting commercial products based around this motor design.
Okay. Thank you very much.
You bet.
Can I be in contact with you later by email or through your website?
Yeah, you can email me anytime. Just personal email is paulmariobabcock.com or paul@paulmariobabcock.com. And I always answer email. Sometimes it takes me a while to get back to them because I travel a lot and have a business to run, but I always get to them eventually.
No, that's fine.
Yeah.
Thank you very much. Thank you.
And if you go to paulmariobabcock.com, there is a contact button there with Paul's contact information.
Hi, my name is Jeremy. I'm from Phoenix, Arizona, and I would like to ask about the voltage spike that comes off the coil and what the switching system does exactly.
Very good. Well, very good question. So that spike is all important, and what that is it's the flyback energy kickback. Every inductor stores energy, and one of our biggest breakthroughs in technology is how we control and use that energy, and that's what we call our magnetic energy recovery process. That spike is the most cursed. That's why we call magnetism is an unruly beast.
Okay,
and that spike is the most transistor-destroying thing ever created. So one of the things we had to do with our motor was learn how to control that, manipulate it, and turn it back to usable work.
So in the process of doing that, are you using capacitors to collect it also?
Oh, yes, absolutely. And it's all about, and that's if you look at our first patent, our switch patent, you will see the basic architecture that we use. And if you look at the videos of the motors and you see those neon light packs, there's about 20 lights series and paralleled out. And that's what we call a transitional voltage clamp that actually clamps and controls that voltage long enough for a matter of a few microseconds to give our what we call our capture circuits time to dump and capture all the energy and dump it into a capacitor. And the capacitor value is matched to the inductor value, so it always charges up well above the input source voltage, so we can circulate it right back into the system and reuse that energy.
And the reason to use the transistors is to switch it from one coil to the next.
Well, what we do is when we energize a coil, this is part of what we do, which I haven't divulged a lot of the science on because I'm kind of stuck in a hard place. A lot of it is what we call trade secrets.
Okay.
But the trick is when you shut a big inductor off, like those coils in our machine are 300 millihenries and they're linear, so they store up its 1/2 L times I squared. So wherever that current is when you turn it off, and that's one of the things about all this technology, you have to hard stop your current, which means you get tremendous amounts of energy right back out of the coil. And the beauty of it is, if you take that energy back out, you get to reuse it again. So what you wind up doing is you suddenly have no core loss, and now you have no high voltage spiking that gets in the way of your transistor transistor switching, and then we get what we call reduced impedance effect, which allows you to use that inductive ramp as a form of control, and now you can dump all kinds of current into inductors that have a lot more amp turns on them, and you get a lot more magnetic field for the energy input you put into it. So there's a whole science we've developed that all revolves around that stored energy in a coil when you turn it off. Because the energizing the coil is one thing, de-energizing it's a whole nother, because the unruly beast will destroy you.
Yeah, it sounds complicated. I have one more question about I know you mentioned in your video the copper wire is resistive, and that's a little bit of something that holds back the amount of power that you can create with this system.
Well, yeah, that's exactly correct. Mother Nature's governor. There's two governors. One is Lenz's reactions, and the other is resistance. So what resistance turns into is it always acts as a current limiter. So if I want to make a coil with a lot of amp turns on it so I can make a much stronger magnetic field for a given current level, the problem with that is I increase the resistance of my coil, and that becomes an I squared R loss factor. You actually don't ever lose energy. It's just suddenly now I have all this current limitation, and I have to use voltage to overcome that current limitation. I squared R means it transforms into heat, and I don't want to transform into heat. I want to keep my resistance low. So that's why it's so important to have a new type of conductor that's much less resistive than copper or silver, because then we can take advantage of amp turns without I squared R loss. And and then that pushes this type of technology into the next level, and that's why I'm so adamant about we need material science to take this even further than where we can. I mean, copper's adequate. I call it pesky copper because it's low enough resistance to where I can actually make it work, but it still has enough resistance to where it really makes me add a lot of mass to the designs that affect the commercial viability. So it's a little bit of a catch-22 there with copper. It works, but I'd sure like to have something a little better.
Is there anything else you guys have tried, like carbon fiber or anything? Or you're looking?
Now that I've actually got the word out, things have been coming to me, but graphene's looking real promising, and there's some other stuff out there I can't talk about because I signed non-disclosure statements. But amazingly, I've actually been seeing that might possibly do it. I'm waiting with bated breath to find out what the test results are.
Awesome. Thank you.
Hey, good evening, gentlemen. I appreciate you setting this up, Aaron, and it's a pleasure to talk to you tonight, Paul.
Oh, great. No problem.
Hey, I was experimenting. In fact, I emailed you about building a small prototype. And something that caught my interest, there's a lot of people talk about coil shorting. And there's a real simple test that can be done with just a mechanical relay that when the current is put into the coil, if you short that current into the coil, obviously you need some resistance on the source because the current would go to infinity when you short it. But if you've got resistance between the source and the short, and you short the coil, that energy stays circulating in the coil. So the idea would be to use two switches, right? You use one switch to energize the coil, another switch to short the coil, and then release the switch that's energizing it. Now that magnetic field will stay in there until the resistance of the winding basically drains it off. Have you looked at doing anything like that to see?
Well, that's the whole science of magnetic energy recovery. There's a whole science to that we've developed about getting all the energy out of a coil, because once again you have resistance in the coil. So it all comes down to it's all basic Ohms and Kirchhoff when it comes to getting energy out of a coil. So if I have a 10 ohm coil and I short it out, like you're saying, after I've energized it, well, that field's collapsing, but it's still loaded up on the 10 ohms of the coil. And so all that energy just burned up as heat. Instead of capturing that energy and being able to use it, you've extended the magnetic field collapse. You've slowed it down because the more current that flows through the coil, it actually slows the collapse down. So the trick to actually capturing that is to actually dump onto a load. It's just considered a Kirchhoff's loop. You know, if I have 1 ohm in the coil and I have 10 ohms in my resistor that I'm loading on, or an impedance of 10 ohms in the cap, well, then 90% of the energy will wind up in the cap and not burn on the coil. So it's just a matter of understanding your Kirchhoff loop and your Ohm's law and knowing what the resistance of your coil is, and that's all part of figured into what our magnetic energy recovery science is. So that's our whole deal, is to extract all that energy out. We call it zero stating the inductor. We extract all that stored energy out, then we turn right around and we can use it externally to do other things with, or we generally feed it right back to the input of the switch on the next cycle and completely recover and reuse all that energy, which is a big part of why our machine is capable of doing what it does. That's how we're able to make really powerful magnetic fields and then get a good part of the energy back and recycle it, and it cuts our input requirements tremendously on power consumption.
So that's how you're saving the energy. Instead of leaving the energy as a magnetic field in the coil producing torque, you just run it full out for as long as it's necessary until you're into the next cycle of the machine.
Well,
you
not
put all
exactly.
back, go to the next cycle.
Because we get what we call reduced impedance effect, we're able to run big coils at much higher frequencies than normally you can. So it's actually a pulse drive system where energy in, and then that energy is turned right around and extracted out, and we control the collapse. So we're still getting torque while the collapse is happening, but then we're storing all that energy into a capacitor in a controlled collapse. And the only place we lose anything to, we don't lose any energy to core material. The only place we don't lose any resistance, so the only place we lose energy is to the resistance in the windings and the switching transistors. And that's the whole deal is to get as much of that energy back as you can through engineering. And then that means, and that's why it's an inequality. That's why it's not directly related to the output. So if I get 99% of my energy back and my output stays the same, well, my COP goes up and up and up as I stop losing that resistance or start getting that resistance out of the way. So it's a whole art and science we've developed, and it's really hard to go into in a conversation like this without losing everybody, but you're on the right track.
The main mechanical problem is if you use bigger wire to lower your resistance, you lose turns, so you lose field.
Yeah, you lose turns. Well, and the way you don't lose turns is then you have a bigger coil, and so that's where the copper problem comes in. Is I can get my resistance down and I can maintain my amp turns, but the problem is suddenly my mass is more than I'm willing to pay, and then my size gets in the way. But if I have a conductor that doesn't do, so there's a compromise in there when you're using copper. So we do pretty good with it, but to take it to where we can have really small machines, small powerful machines, I think graphene is probably going to be the answer to that.
And then you can go hundreds of amps in a small device, and sky's the limit.
And create huge, powerful fields, get all that energy back, just keep it recirculated so you got these powerful fields that are driving the motor, but I'm paying very little input cost for them.
Do you have switching circuits in mind that will start to be able to deal with these kind of amperages?
Oh, yeah, that's the beauty of semiconductors today is when I started out in college in the mid-'70s, just about every component made fit in a book that was about an inch thick. Now, the amount of components, especially switching and power components, and power levels has been exponential. So the electric train and electric buses and electric ship thing has made all these huge high-power IGBT modules and SCRs, and I mean, you can switch power into the thousands of amps at thousands of volts already made. So that stuff's there, ready to go.
Yeah, that's the easy part. I have 5 MOSFETs that can each do over 200 amps apiece, so that's not an issue if you can keep the wires from melting down.
Yeah, well, that, and also keep the thing with switching transistors is if you let switching noise is your worst frickin' enemy. So that's what happens when you turn the MOSFETs off in that coil. And if you leave that thing open on a high impedance, you get this, it's classic Faraday, you get a high-speed collapse of that field, and it generates all kinds of instantaneous joules at real high frequencies, and the harmonics just zip right through your inelectric capacitance and your parts and turns everything on, and then boom.
Yeah.
So that's one of our trade secrets.
The coil is kind of like a spring, and when it releases from both sides.
Oh,
so the other side ends up back on your power rail, and that throws off the gate voltage, and you got problems.
It's really simple. 1 joule of energy dissipated in a microsecond is 1,000,000 watt seconds for a microsecond.
Yep.
That 1,000,000 watt seconds of energy travels so fast and gets right into the barrier junctions in your transistor and just evaporates them. Even though it was only a joule, you know, then it turns everything on, and then the power supply just decides to eat everything that you've got and dead shorts everything.
Yep.
And we went through thousands of transistors figuring out and mastering how to overcome that problem. And that was one of the keys to making this all possible.
Well, it's a very interesting machine you've put together, and your talk about the abundant inequality. I hope everybody sees that, because there's lots of places where you can back your system up against a wall that you don't have to pay for.
Well, and that's the whole thing. That's it took me years to actually put what we knew into a form that people could understand, that the abundant inequality concept is the most important thing there is to understand, because it's hidden. That it's the facts of life that magnetism has an energy value that can be extracted from it, and the abundant inequality shows where the electrical physics actually say exactly that. And you know, it's just hardcore empirical observation. So I'm not the first guy to say it, and I won't be the last. There's lots of guys out there who have produced these effects, documented it, had science, and not quacks, but people who knew what they were doing, very highly skilled people. The only problem is making it a commercially viable product. And that's where we've really focused since we started this, is to define it in the known laws of physics where nobody can argue with how the concepts work, then produce the electronic switching that made it possible. And, technology and material science caught up to make all this possible, because back in the 80s and 70s, there was lots of demo units, but they'd only run for a few minutes at a time, and very unruly. Mastering the magnetic beast with transistors was the big chore.
Well, Paul, I could probably sit and talk to you all night. You got other callers. I better let them have a shot.
Okay.
Much appreciated.
No sweat. Great talking to you.
Okay.
Yeah, if you have another question later during this call, just hit *5 and you can get back on there. No problem.
This is Yoki, a.k.a. Harvey. Nice to talk to you.
Nice to talk to you.
I think graphene's not going to make it in time for the competition, which I'm optimistic will present itself to you shortly.
Oh, hey, I know who you are. Yeah, I'm the guy that I've been keeping it kind of on the down low. So I'm a hoping, man. I'm a hoping. I got my fingers crossed big time.
I have 11 possible materials that have progressively lower resistance, and I'm planning to create number one for you possibly in the next couple of days, and I'm optimistic that it will provide you with something that is improvement over copper, but I don't know whether it's enough of an improvement. We can go all the way to room temperature. Actually, you can go all the way. You don't want me to go that far, I know.
If we can get to half or even a third of, anything, as long as it's, it can be is malleable, can be used like wire, coated with proper.
What I have is ductile.
A huge breakthrough.
But I have this ductile, and we can go easily to half or 1/6 or 1/12 or 1/125th, depending on what you need, and you can have those extra turns that you want that will compactify this, but not right instantly.
Outstanding.
We need you and I to have a conversation about this. I don't have.
That's kind of like I've been keeping our relationship kind of on the down low and not tipping the beans too much on it till we get some things.
Much appreciated. There's a much larger picture at the other end of the theoretically known limitations that has a lot of other implications, and I'd like to try to get a multiplicity of options shown quickly. I can show you the number 1 and the number 6 wires of 11 probably soon, hopefully in a few days, but it's been a real haul.
I've been waiting with bated breath.
It's been a real haul to make it happen. There's been one catastrophe after another trying to get it to happen. I was held up because the chemicals were held up in another country, and have been. I went to the laboratory today, and it's locked, and I had access that I don't have access now, and we're setting up in a garage and all sorts of other stuff. Providing that everything works, maybe in a few days, God willing, and I hope that we'll be able to talk with you within a week with something solid.
Oh, that's outstanding, because it's a major thing with this kind of technology, and it's just like huge breakthrough, and we just got to keep all their ducks in a row as we go along.
Mm-hmm. I missed the beginning of your talk. I just tuned in about 5 minutes ago, and I just have the sense that what you were doing is rapidly discharging energy through an inductor and taking advantage of the inductive rebound in some way?
Yeah, well, I'm able to get all the electricity. The only thing is what we call our magnetic energy recovery process. So we're able to drive coils at high frequency, DC, and we put pulses of energy into them. We get this very powerful magnetic field, and then we turn right around and take that energy back out and recycle it. And we don't have any core loss. It's extremely efficient. The only thing we lose energy to is the resistance of the wire. So I want to take advantage of amp turns to get stronger magnetic field for less energy input. And if I have low resistance wire and I don't have any R that makes me turn my voltage up to hit certain current levels, the current levels I'm looking for, that means I'm getting extremely powerful fields for very little energy input. And how that translates over to the mechanical side is so I'm reducing the input power down and down and down and down as I take the resistance out. Pretty soon I have hardly no input, but as long as I hit the same current level, then my mechanical output doesn't change a bit. So I'm engineering this system into where I can go way below anything that's considered unity by just engineering the resistance out of the windings. combined
So
process.
as we drop resistance, you've told me that you do not want to go to zero. For some reason, some resistance is needed, right?
Yeah, because once you go superconducting, then all you have is a static magnetic field. If I'm close to that and I can just leak a little bit of current in, then I have to be able to turn my field on and off and recover that input energy to output energy. So if the field goes static because it went superconducting, now I don't have a motor because I can't turn the fields on and off the way I need.
But you could switch a superconducting coil on and off. It would be static.
The closer you get to superconducting, so basically all I have is the input energy is just a little bit enough to get those. As the domains flip easier and easier and easier, my input cost goes down and down and down and down, and I get right down to close to superconducting. And then my input watts, you're talking milliwatts to be able to control these huge Gauss fields by being able to turn them on and off and switch them at will. And so you're talking
Yeah.
And that's a huge deal, man. It fits into our designs to where you're talking incredibly powerful motors for just little bits of input energy.
I don't quite understand why you can't go to zero.
Well, just because when you hit zero, when you hit superconductivity, now you have, then I don't need current, but I have to have some way to turn that field on and off. And once it goes superconducting, if I have just a little close to superconducting, not quite, then I can flip those domains.
Oh, I see. Your problem is that you blow the transistors. If the resistance is zero, the current goes up to infinity. I understand.
Yeah, that's part of it. And also I need to be able to flip the domains in the wire back and forth because I need to change polarity back and forth. So if I go superconducting, I have no polarity control, or I lose all my control. But anything, the closer you get to zero, the better. Just so long as the domains just don't lock up and stay solid when they hit the superconducting. I need to be able to rotate the domains, but the less energy I expend to rotate those domains, the better. So, but once I get past half and down to a third of what copper is, 10% would be awesome. If it was 100th, 120th, even 1/1200th, anything in that range, to where the lower that gets, the lower I can lower my voltage to maintain the same current, and input watts drops to nothing. My fields are able to move and switch polarities, and then that way I can create the mechanical force. And so that's part of the engineering challenges that dealing with that R.
But I'll see what we can do. We're still at a laboratory stage and an experimental stage. The data's still preliminary, and we don't have the kind of equipment that Dr. Haralick and other people have to prove.
I understand. I've been messaging back and forth with Bob a little bit, kind of keeping track of what's going on there, and I can't wait to come out and see you guys so we can get our heads together and do some brainstorming. And we want this to get out to guys like you that are on these forums who can understand the theory behind it all, why it works, and then be one of the 50,000, 100,000, who knows how many entrepreneurs that go out and use this new technology to take it to the world. That's all about and being above board in public a little bit. Those kind of people, those kind of things come along, but I can say in all my years of doing this, I've never been approached or suppressed directly to my face. Nobody's ever stole my patents. Nobody's ever approached me and tried to shut me down. Out there in the big business world where we're competing with other big companies over standard stuff like lighting and stuff, oh my God, that's brutal. But as far as this kind of science work, nobody's ever bothered me. So
thank you for
I'll be in touch, Harvey. It's good talking to you.
Hi, I have another question. My name's Jeremy from Phoenix. I asked a question earlier, but I was wondering about the products that are for sale currently through Flyback Energy. Is there a product for sale right now that is purchasable?
Well, flyback, what we've done for many years is this motor and this motor patent were basically on the back burner. So what flyback we're doing is we're doing industrial products for industrial entities using our magnetic energy recovery process for lighting systems and big motors and a bunch of different stuff. So that's the only products we have available are commercial products. But what we're doing is developing, trying to take our motor designs to a commercial level. So we're getting geared back up. Our motor's been on hold for about almost 10 years now, because when we first came out to the world with it, we did not get a warm reception. We got beat with a club, basically. And so to develop a company and whatnot, we took some of our science and we applied it to standard physics, standard ballast motors, and that's what we have available to the public right now. But for this kind of technology, no, we have nothing that's available.
Okay, thank you. So industrial products only.
We're trying to get the science out there and help other inventors and innovators study and understand how magnetics and energy really works and start applying these principles. And so the public understands that it's real and that it works, and other people can verify it. 1,000 inventors and experimenters out there get more done than 10 million scientists typically. So
I was thinking for like small commercial application, is there any product available like that lighting?
Yeah, we have our lighting controller stuff, but it's we've had a hard time implementing it in the United States for reasons. But yeah, if you go to our website, flybackenergy.com, it's all on there.
Is it even? Can we use it in the United States? Is there something?
Oh yeah, it's all certified.
Okay.
It works good. It's a magnetic ballast energy controller for sports lightings and warehouses and.
Is there something for like?
Yeah, we've been implementing most of that technology in the Middle East. That's why I've been in Bahrain and Saudi Arabia a lot in the last couple of years, working with a Masdar Institute, which is kind of like the Electric Power Research Institute here in the States, getting all of our stuff verified for manufacture to start selling it as a light energy saver for big municipal, lighting systems and warehouses, and we came out smelling like a rose. It's a great product.
So is the lighting controller the only thing, or is there something that also does helping the AC units use less energy? That's the only thing that we can sell that's certified with a UL sticker on it. We have a laboratory full of awesome stuff that's just amazing. We run stuff directly off solar and do all kinds of stuff. But the problem with selling it is we have to get certifications on it. And just to get our lighting controller certified costs us basically $1 million just to get that sticker on. Wow.
So that's why some of our hang-up has been getting our products out, is it just takes so much. It's just incredible amounts of money just to have a legal product to sell.
Wow. So the inverter, so you also may have an inverter, but it's not listed yet?
Right. We've got one of the world's best inverter technologies by far and above using our MER process, and that's part of what we're going through is the UL 512. Oh, it's just an amazing amount. And then suddenly you have ETL and UL. They're trying to decide they're going to be your engineers, and they drive your cost up and shoot your design. It's just this painful, expensive process. And that's what slowed us down, the economic downturn. And we're out there, we're a little company out there trying to get into a big marketplace with big players, and it's not an easy task, So, you have to deal with the venture capitalists and your stockholders, and, that's why I'd spend a lot more time doing this. But Flyback Energy is, it eats up 90% of my time, and that's fine because that's the platform we created to do it. But It's just an amazing process you have to go through to get anything to the public that you can legally sell.
Well, thanks for enlightening me on that. I appreciate.
I wish it was.
I appreciate your. Yeah,
I wish that wasn't the case. I should just be able to go make something and sell it to anybody. But if it goes in somebody's building, then their insurance company, it's just a bureaucratic nightmare. So, that's what keeps a lot of small companies from prospering or getting out of the startup stage is exactly that. That's why people and companies write code, because you don't have to deal with those issues.
Thanks for answering my questions. I appreciate it.
No sweat.
Thank you, sir. This is Chris from Vancouver, Washington.
Hi, Chris.
Yes. I came to the call primarily on the phrase, build yours today. How might I do that?
How would you like to build a device?
Yes, sir.
Well, here's what I recommend for people that want to start studying these principles. If right now you can buy a very commercialized version, all the parts and pieces to build a Bedini schoolgirl motor that's like a Ferrari compared to the little prototypes that were originally built, and can explore and build all these principles. You can build a Cadillac version of it for about $3,000 and buy all the parts and pieces. And if you go to Aaron's site, you can find all the links right to that stuff.
And where the kit is available to put together, or just the patent?
And if you go to the 2016 Energy Conference, there's some, look at Peter Linderman's presentation. He built one just for the conference. And I highly recommend buying John and Peter's latest book on the definitive guide to the schoolgirl motor. And it's all in there, how the thing works, how you can extract energy out of it without inducing Lentz reactions. Basically, it's all about algebraic inequality, and it expresses those very well. And if you build these things right, they work quite well.
Is there a sufficient shaft horsepower to drive anything?
Well, that's the beauty of, you don't need a lot of horsepower because you're overcoming Lentz's law through geometric configuration, to where you get power out without creating a drag force. And Peter and John have demonstrated this quite well, and now they've got those versions of motors basically up to like a Cadillac state. It's just all the circuit boards are built, the coils are wound, all the parts and pieces and framework, the magnets. You just buy it and kit it up, and the more coils you add, the more voltage you run it at, the faster it turns, and the faster it turns, the more energy you can get out of the generating coils without causing any drag force. And that's the whole idea, is to just not create drag force, so you don't need lots of horsepower or torque. And that's the secret of that. And it's a great place to start because it's fairly simple circuitry. Like, our motor is a complex machine, and it's generally beyond the skill level of the average guy to build something like that. But the schoolgirl motor is a great place to start, especially the sophisticated versions they got. That you can buy all the parts and pieces you want. You don't have to build it all at once, but it's a great place to go. And just buy the latest book that they've created on SG and read that book, and you'll see what I'm talking about.
I hope so. I've been trying to source the coils to mount against the magnets and trying to find the matching coils with the transistor. It gets rather frustrating.
You can buy it already pre-made and ready to go, all tested, and it's all right there. All you got to do is log onto their website, and I'm sure Aaron can set you right up on
to
that.
the energetic forum.
Energetic form, yeah.
Well, on Tom Child's website is TeslaGenix, Tesla, GENX.com, and he has coils and the circuit board kits, and you can buy as many transistors as you want. They're all matched. They're the MJL 21194s. But all the matched transistors, circuit boards, coils that are pre-wound, you can get them with pretty much any number of turns you want, all the way up to about 8 power windings and 1 trigger on 1 coil. And that's the easiest route to go.
Yeah, and then
trying to put together one of these kits and then have that go through the UL laboratories must take another $1 million. So I can appreciate the effort.
Okay, thank you.
Thank you, Paul, for bringing this to the public.
Oh, no problem.
See you soon. Bye-bye.
You bet.
Hey, Paul, it's Giovanni Angelo.
Oh, hey, how you doing?
Hey, pretty good. I caught wind of this conference. I wanted to chime in. I'm between cities a lot, and I just noticed you had a Vancouver gentleman and you're a Phoenix gentleman, Jeremy. I'm all over the place, and I was wondering, I just had a quick question. Do you have a networking list that people can volunteer to talk with like-minded people?
Well, that's one of the things I'm putting my personal website up, and I'm working on getting all that kind of stuff put on there.
Okay. I'm sorry I interrupted you. I'm totally energized by this conversation, so there you have it.
Yeah, there's been quite, since Aaron and Peter started putting the conference on, and Aaron especially the last couple of years, it's been growing exponentially to where the conference has caused just an incredible amount of collaboration and networking between inventors that before wasn't really going on, because first we didn't have a safe forum to get up and show our stuff, but it's brought an amazing amount of collaboration together. So I've seen some things explode exponentially here, and the science, the devices. I mean, just on and on. I mean, when you got guys like Graham Gunderson and Jim Murray and Eric Dollard, all
sure.
every year, a couple times a year, that's just been amazing. Graham blew me away at the Energy Conference. I thought his was the best presentation last year. I mean, he did it. He got right up there and showed you more out than in with his implosion transformer, and very similar to the SERPs, but a different approach. But it just, there you go. What part of seeing it don't you get? So
yeah.
I highly recommend.
Well, can I make a suggestion? Maybe a very simple kind of Excel location where somebody like me would put my name and maybe a specialty and an interest, and people can go down the list and put my contact number up there and see if collaboration can happen. And that's really easy to put in a PHP file.
Yeah, that's a good plan, and I was thinking along similar lines as, what I'm really trying to do is inspire people to start like local clubs, to start.
That's exactly what I had in mind. And when I come visit,
you get 4 or 5 guys together, and you each put $20 a week. Someone's got a bedroom or a garage, and you start doing this stuff and really exploring the science, because that's what I really try to get through to people, is people need to understand the hard empirical science behind this stuff, because it's not foo-foo. I mean, it's just hard physics. And and once you understand it, it's just like understanding how your car works. You have pistons, they turn on the crankshaft, the gas explodes when the valves close and the spark goes off. Same stuff.
Right. But you know what, that's just it, Paul. And I may have one part of the equation and somebody else might have the other part. And we've got, just like a regular engineering discussion, it's like, oh, okay, the light bulb turns on for both of you at the same time when people can collaborate. And plus it would help sell your products too. So,
and my deal is to get this to a commercial level of something that, somebody, once they have it, it runs and runs and runs, and it's cost effective. But if the public doesn't understand how it works, because this stuff is as real as it gets, it's totally legitimate, and the deal is, if we want it, we have to do it ourselves, because if you're waiting on corporations, the system, the government, you're just going to be a long time in the waiting. So that's why the knowledge is the power, and that's my deal is where if we have the knowledge, it can't be stopped, and that's what we're trying to do, is spread the knowledge, and that's all this collaboration that's happened between inventors has really expanded the knowledge quick. You know.
Well, if you don't mind, I could put my phone number out there. I mean.
Yeah, and that's what on my website I want to get. I'll be doing some posts, and I'm just getting ready to put out the monthly newsletter and catch up on some posts. I'm a little behind because I've been pretty wrapped up since the energy conference, but I got a window of opportunity here. So that was one of the things I was going to put on there, is suggesting that people just create, start collaborating between each other and start experimenting, trading knowledge. I'm going to try and get like a syllabus and some kind of training book up, as time allows, and, so the website will be kind of a center of that, and your suggestion is well taken, and it's a great suggestion.
Okay, Paul, I got one more quick question, and that is, are you trying to raise money to help push this through? Because
it's like this. As a corporation that we are, I cannot accept any money because, the company owns all the patents and everything. I cannot accept the Securities and Exchange Commission, the other government agent which we have to deal with. We have severe rules. But what I encourage people to do is start pooling their money together and start doing this on their own. Like the schoolgirl motor is a great place to start. And then when
how's that helping? How's that helping you, though? I mean, I don't understand.
I deal with, we raise money through, we have to do accredited investors. So I have stockholders and bankers. I mean, we had to do it the fully legitimate way, which is the full corporation, which means we're under the rules of the state of Washington and the federal government. But that doesn't mean I can't be involved with other organizations that are pushing the concepts, doing exploratory stuff. I can be a board member, advisor, whatever. There's lots of ways to advance it. It's just if I'm doing it through my company and I have to protect my company's intellectual property, and all that stuff. But as far as getting the science out, and like I say, there's a lot simpler ways to do this than my motor.
Okay, what happens if I, a couple of the collaborators get together, invent something, use your patent, and then it gets evaluated through that? Would that be a possibility?
Well, that's just somebody, we're always into somebody who figures they want to need our switch, they want to license it. That's always possibilities. But right now, there's all kinds of things to do, and there's nothing like getting your hands on it and making this stuff work,
Right. Okay.
And I'll be putting out more experiments, and I also want to create a handbook of simple circuits, and it's if everybody, like I say, it's really simple. What holds this technology back from the world is that people that start companies and try to bring it to the public, they're startups, right? So they don't have any outside revenue to support everything.
Yeah, sure. I know.
But if you're a regular corporation, you've got all this outside revenue and ongoing revenue, so you can peel off that, and you get to develop all your stuff off your profits. And those kind of companies don't want anything to do with the kind of technology we're creating. So there's this gap of you can invent it, you get your prototypes done, and then all of a sudden, you've got to raise the money and the millions of dollars to turn it into a commercial product and play the system game. And that's where everybody dies because the system doesn't let you raise that capital you need.
Well, we won't let you die, Paul.
Oh, there you go. And see, then that's what I try to tell people. If you start an organization, see, I can't take your money
Okay.
But if you started an organization and if you had 1,000 people doing $10 a week, what's that add up into a year, right?
Right.
So that's the deal is just everybody pool a few shekels, give up one latte a week, and 20 people can put an amazing amount of money together in a year's time. And with that, and you're an organization, then there's something I can do with it. But right now I've got Securities and Exchange Commission rules that says I can't take, unless I'm operating outside of flyback at some kind of advisory capacity or whatever, I have to be very careful legally about taking other people's money.
Yeah. Okay. Well, I'll let you go. Somebody else is probably wanting to chime in, so it's good talking to you, Paul, and I'll have to stay in touch. Okay. Thanks a lot.
Glad to hear. I'll be okay, man. We'll talk next time.
Okay, Paul. Bye.
Okay, and let's see, Giovanni. And as far as local collaboration, at least in the Spokane area, I do have a website, SpokaneTeslaSociety.com. If you want to join that mailing list, we haven't had any meetings yet, but I'd like to have a couple before the end of the year. And I know there's different groups like that around the country and internationally and stuff, but at the one for Spokane, I think Paul has expressed interest in being involved in some of the others from the conference. And maybe if we could do it maybe once a month or something, but that's...
Yeah, I would like to see a movement just kind of quietly across the country where little groups start pulling a few shekels together and then just go about, creating this stuff and then supporting the companies and these startups to drive it into the marketplace. And, if we want to beat the big companies and the big money folks, that's how it has to go. And we don't have to be all that organized, It's, and that's why the stuff isn't going anywhere without public participation. And that's what we're trying to pull off.
Hi, this is Kelly Groves calling from Houston. And the guy that was talking about the how to meet people, Aaron, I think your website would be great for that. I'd love to be able to, put my name and email on there and be able to search other people's names and email and phone number and trying to find people in the Houston area to meet up with.
Yeah, maybe as far as any websites I have right now, probably energeticforum.com would probably be the best. I can probably start a forum in there, like a geographical section or whatever for networking. And
yeah, right now there's no way to search that though, is there?
No.
Yeah, kind of a Craigslist for free energy experimenters.
Yeah, probably kind of collaborate personally, like something like that in the forum. I could probably make something where I had a little sub-forum thing for each state where, if you're in Texas, you're going to the Texas one, just put your, name, number, and email, name and phone number and who you're looking to connect with. And anybody else in Texas could go on that same one. That'd probably be about the easiest. I know that at the conference, the 2016 conference we just had, there's some interest in putting together a directory where at least people from the conference could connect with each other and when I send out emails and stuff like that, because I was actually going to put together a directory in print that could be mailed out to the attendees. Not very many people responded. It's got energy's kind of high at the conference, and then, afterwards people's kind of back into their lives, so I didn't get much of a response. But that's definitely something I could probably do an energetic forum. Just make a forum and have one for each state where, people can just post their contact info. Then it's up to anybody else to just, take it upon themselves to put their own info and contact others. So
that would be great. I'm sure a lot of people would appreciate that. And Paul, I just wanted to thank you for all your lectures. I've bought them all, and I just have one question. I don't know if it's easy to explain. The reduced impedance effect. How does that happen?
Well, because the way Mother Nature sets up, if you know anything about energizing coils, or especially if you're trying to drive, if you understand what the description of a Henry is when a coil or an inductor resists current change. And so that's what creates impedance, right? So if I'm trying to run anything at frequency into a coil, the more henries there is in that coil, the more it resists change in current flow. So now the energy that you put into that coil turns right around and works directly against you. And so you can't, the more henries, the less frequency I can drive into that, because it gets more and more oppositional to current changes. So what we do is where Mother Nature will actually give you one freebie when the coil is completely de-energized and there's no previous magnetic field bucking against you, and you turn that coil on, you will get a perfect inductive ramp, and you will get, in a very short order of time, you'll get this inrush current, and that field will charge right up. And then the second that your current reverses or drops, goes the other direction, well, then that previous magnetic field suddenly opposes you. So what we do is right when we hit the peak current, from the first time we turn it on, we shut the input power off, and then we turn right around and extract all the energy right out of that coil in a short amount of time and turn it right back to a de-energized state.
So that's what you're
switching. It never has any energy to turn around and oppose the next coming cycle. So what that does is it gets what we call reduced impedance effect. All of a sudden we have great big inductors that we can run high frequency current through it. It's like typically like the coils we have on our machine. Those are 300 millihenry coils. And if I can plug them right into the wall socket at 60 cycles, and they won't hardly draw a milliamp because of impedance. But when we run it on the machine using our reduced impedance effect by zero-stating the coils like we do, I can run those coils all day long at 400 hertz and get major current into them. It's like all the impedance has gone away, and it's simply from never letting that field ever turn around and impose you. We take it back out and we make a special period in the cycle for it to extract that energy out, and that's what creates reduced impedance effect.
Okay. I got it now. All righty. That's all I have. Thank you very much for your time. I enjoyed listening to all.
Thanks, Kelly.
Thank you, Aaron.
Let's see. Ed, go ahead and introduce yourself if you got any questions. This is Ed with the Ubuntu USA organization, which is Michael Tellinger's.
Oh, I know, Ed. I need to send Ed an email here I've been trying to get to for the last couple of days.
Well, here he is.
Hey,
Ed, how you doing?
Hi, Paul. Oh, I'm doing great, Paul. Yeah, I've been busy. I just wanted to thank you, for being so eloquently describing how you can get usable energy out of magnetism, because I've always had a problem trying to explain this to people and understanding it. But
it only took me 30 years to figure out how to explain it to people.
Yeah, but the way that you explain it, I mean, I've shown it to my friends and they all get it. So it's amazing. You're able to describe it so simply that a child can understand it. So what it inspired me to, I sent you that model for the permanent magnet motor, and I just wanted to let you know I have the 3D printing of the rotor. Should arrive in tomorrow.
All right, on. You're coming along.
Yeah. Yeah. I actually had to embed the magnets into the rotor so that they're perfectly aligned. It'll be easier to glue them up. And Harvey Kaplan is actually going to help me with that, by the way. I was just talking to him today. And just to let you know, Michael Tellinger is flying in Wednesday, and he's going to be in the States all the way through October 3rd, and I'm going to be staying with him most of that time. And we'll be meeting with Professor Haralick on Thursday.
Right on.
New York University. So
he did get back to you.
Hey, Bob, say hey for me. I love that guy.
Yeah, I like Aaron. I'm sorry, what did you say, Aaron?
Oh, so yeah, I didn't know whether Professor Hartlett got back to you or not when I forwarded him the message.
Oh, yes, he did. We already have it scheduled. Yes. So
okay.
I'll be bringing Michael Tellinger. Yeah, I'll be bringing Michael Tellinger up there to meet with him. I'd like to also get Harvey there if possible. But I was just wondering, have you seen this Miller-Coulson magnetic motor? Because I've got an email from Aaron that linked to the on Energetic Forum, and I looked at this thing, and I'm just shocked. It's a permanent magnet drive. I'm looking at the patent right now and trying to figure out how it works. Have you had a chance to look at that?
I've been so busy since the energy conference, I haven't had much time to research anything. But I've seen many videos of permanent magnet motors, and I've been dying to get my hand on one to test them because I don't believe videos until I get my hands on it. But
right, yeah. So I'm looking at the patent. I'm trying.
But I know some guys that have some designs, and I've heard the tales, and I know it's quite possible that they'll rock and roll because all you got to do is create that imbalance between the two magnetic bodies, and the work will pop right out.
Right, and that's the trick to it.
Yeah. And I know where there's a gentleman, I can't remember if it's in Sweden or Switzerland, but he's a hippie guy, and he lives out in the woods, but he built a set of magnets that runs on a ring, and it's the first one that I know of, but it's been running for years, and it's just very simply creates an imbalance between the magnetism and this ball that's rotating around this track on a ring. And the thing just runs and runs and runs and runs. He has it under lock and key and monitored. And I think it's about 10 years now that thing's been running and hasn't stopped. And it's just this ball going around on this track, and it just keeps going.
I've seen that.
Yeah,
that's
it's cool, man. Right there was the living proof to me. That one I didn't need to test it to get at what he was doing. And it's the same thing that all these machines do. It's creating, and they're all work on the same basic principles, whether it's Bedini or Newman or what we're doing, permanent magnet motors. It's all pretty much, there's just the three basic principles that are the ones that you'll find in almost all of them.
Yeah, I'd seen Joseph Newman at the Superdome. I used to live in Mississippi. I live in Covington. And this was right after I graduated. I had a degree in electrical engineering. And so I went to the Superdome and saw his demonstration. And from then on, it's always been something I've always wanted to understand how it works. So I've been studying. His theories, basic observation of magnetics. I based a lot of what I do on, he was one of my main inspirations. That's when it became my life mission to figure this all out and to make it a practical reality. And so that's been almost 30 years ago that I've been at this as a life mission. But, it's amazing what I've learned along the way, and there's a lot more to learn. So I'm just trying to pass on the knowledge now, and the time is right. The time is now to do this. Yeah, I agree. Yeah. I've learned a lot about magnetism myself. I mean, Ken Wheeler his book is really fascinating. I don't know.
Yeah, I'm in the process of reading that one right now, and there's anybody that actually tells you that they understand what magnetism is just deluding themselves.
Yeah.
Because there's just this incredible, everybody has a model, and the models express some version of magnetism as you understand it in a physical sense. But nobody can really tell you how it works and what it really is. And, we just have to build our models and work off our models, to get results. And that's where I really like Joseph Newman's, gyroscopic particle model. It's so practical to get practical results out of, once you know what the engineering challenges are. And
it kind of reminds me of Ed Leeds-Gallman's description of magnetism. I've ever read his book.
Yeah, very
pretty simplistic. Yeah.
Gyroscopic particle theory, because even Einstein, de Haas, all these guys were calling it out. And they were even calling into question Maxwell's equation, that there was all this stuff hidden in there, but when they went to it as trying to claim it was, even they weren't brave enough to go and make that step and claim that magnetism has an energy value. Even though they wanted to, they just didn't want the politics of it.
Yeah, I know exactly. I see it clearly. I understand the game.
Yeah.
We're changing, and that's what Ubuntu, and that was Ubuntu's one of our missions is to implement free energy in our communities. So we're opening up the first Ubuntu community in Bolton Valley, Vermont, on October 1st. Yeah, I'm going to be there, and we're also opening one in Ohio.
Say hello for me. I've watched a few of his videos with Jim Mars and whatnot.
Yeah, he's a dynamic speaker. So I'm going with him to Greenfire, Ohio, where we'll have another community. So
outstanding. Well, that's the kind of things I want. Communities like that push for this technology will get it. Right now I'm dealing with some native communities in Alaska that are asking about it, so I have to go up there and give a talk probably next month. And it's catching on like wildfire. People are seeing that, wow, this is, and that's what I'm trying to show people is, hey, this isn't rocket science. Once you understand the model, here's why it's real, and here's why it works. It's just making that leap from there to the commercialized aspect of it, when we're working against the business entities that don't want anything to do with it. So we have to figure out how to solve that problem of making it real. But that's where the public...
Right, to bring it out to the market.
Yeah, getting it out that's where the public comes in. Public support for small companies, small entrepreneurs, pooling their money resources together to actually, drive this into, to drive it into reality, And once people understand that it is real and that they can pool a few shekels together to make it happen, I think it'll take off great.
Yeah. Well, we're going to do what we can to get it implemented in our communities and hope that it'll spread from that. That's not going to make it out to any market, but it'll be utilized in our community.
And I know the inventors bringing this stuff to the world have put, every penny they make, they pour into it. God, if I just had the money back I put into it out of my own pocket, I could go on a hell of a party.
And for connectors, someone has asked how we can connect with people in your local area. Well, ubuntuplanet.org, we have circles where you can connect with people in a geographic location. And you can set up, it's almost like a forum where you can have interactive discussions. And we're going to I'm working with our IT guy to create a center of excellence for energy, for free energy research, and for inventors as well. And so I'll keep you posted on that. Hopefully, that we can, and we'll be an affiliated in Aaron's affiliated program as well. This kind of
sounds good.
Yeah. Okay. That's all I have.
All right. Thanks, Ed.
Okay, I'll drop you an email when I get a chance here.
Okay. No problem.
And Ed, you said that was ubuntuplanet.org?
Yes. Yeah. And the USA chapter is usa.ubuntuplanet.org. So the worldwide chapter is just ubuntuplanet.org. And you can see the technology. It's pretty. The main website is ubuntuplanet.org.
Okay, there's not like ubuntuusa.org or something?
No, the USA chapter is usa.ubuntuplanet.org. I can email it to you.
Okay.
And I can point you to where you can see the technology that is used for helping people to connect to it geographically.
And is that the website
really cool.
Went online a couple months ago? Is that the website that just came online?
It's been out for several months. I'm not sure how long.
Okay.
But the USA.ubuntuplanet.org is fairly new. But ubuntuplanet.org is a little bit older. USA version came out right afterwards. Okay. We have chapters all around the world.
Okay. Thanks, Ed.
You're welcome.
Yeah, take care, Ed. Good talking to you.
You too. Good talking to you.
Let's see. We'll probably take maybe one more question. Go ahead and wrap it up.
Yeah, that's fine.
Okay. Let's see. Looks like Harvey's the only one with this.
Hi. I don't want to take much time of your valuable little time left, but I have this thing I wanted to share with you, which is the basis of a theory of how magnetism works. And it is my observation that if you combine the amount of pasta that you eat with an exact equal amount of antipasta, the calories cancel.
It makes sense.
No, actually, really, the amazing difficulty of figuring out what magnetism actually is the source of an astonishing number of interesting theories. I think that Haralick's work in defining that edge where there's a second vortex is going to turn out to be pretty important when we figure out how to use it.
In fact, that was just he left his slide deck with me, and I've been going over it off and on here since the energy conference. And you know, there was a lot of very similar information that Haralick is coming up with, research that was done all from like 1885 right on up till about 1930, and there was lots of books that talked about the third field, you know, and transformers and invisible fields and vortexes, and all of a sudden about 1931, 32, when the Rockefeller-driven engineering programs took over the colleges, all that stuff got scrubbed right out of the books, you know. And just the E&M, just basic E&M theory took over, and none of the other stuff was given, you know, was all given short shrift.
Part of that is a conscientious effort by those who control the secret space program and various other black projects by the government to suppress information that they know that they don't want us to figure out.
Yeah, well, there you go. Well, now it's inevitable. We have to figure it out, you know, because if we don't, they're going to use, you know. And so now just people, you know, common folks there's always innovators out there who are constantly questioning the status quo take on things. And, man, all with Tesla, there was so many incredible minds that came along from the late 1800s till the mid-30s. And, man, it was just like a renaissance of thinkers, man. And what they gave us and what we got, you know, was a crime what they did. I mean, Schomburger to Russell to Tesla to just on and on. They had the magnetic, you know, energy resonance healing to just on and on and on, and they stole it all from us so they can burn coal and charge us money for burning coal.
Well, that's got to end. We are going to move to a free energy economy by hook or crook soon, and permanently taken out.
That's why we want them to give it to us. That's why we got to do it on our own.
Okay, we're going to do what? Let's see, maybe one quick question, and then go ahead and wrap it up.
Yeah, that works for me.
Okay, so this will be the last question here.
Okay, Aaron, this is Joe Brown. I want to thank you and Paul for putting this on. I think it was great. I must also say that sometime in the future when you hold these again, it would be very beneficial to the rest of us if you would put some kind of a mute button on guys who just want to call in and bloviate about their own accomplishments. But other than that, I appreciate the both of you putting yourselves out there to help teach the rest of us something. And I'm looking forward to the next time. But and I'm looking forward to the 17 meeting again. Anyway, I want to thank you very much. Have nothing else to say from me. Thank you.
Okay, thank you.
Thanks a lot, Joe. Appreciate it. Okay, well, I just wanted to mention Paul's website again. So Paul does have a new website that's coming together. He's got a little bit of stuff on there right now, and he will be starting to put up regular articles on the blog link, and it'll be a work in progress. That's paulmariobabcock.com, paulmariobabcock.com, and in the right column at top, there's a name and email form there if you want to join his personal list. And the stuff that will be going out on that list will be invitations to these live calls or, any other announcements regarding Paul's work. And also as far as next year's conference, like Joe just mentioned in 2017, the website for the conference is EnergyScienceConference.com. That's EnergyScienceConference.com. And you can click the registration button and you can go ahead and pre-register. Actually, about 1/4 of the seats have actually already been registered, not taking any payments or anything. We don't even know what the schedule or what the whole agenda for next year is going to be. But if you do want to at least pre-register there, because it is limited to 150 seats, and anybody that came this year, you can see that it was, we sold out of every single seat, 2 months ahead of time. And so if we do something in 2017, I'm pretty sure it's going to be just as popular. It's going to fill up pretty quick. Let's see. Do you have any other announcements or anything you want to add, Paul, before we wrap it up?
No, other than I'll be putting some stuff on I'm getting some stuff wrapped up here, so I'll be able to go in and put more content on the website. I'm going to put a lot of stuff on there and a lot of different diverse subjects. So just show a little patience, and you'll see some good stuff pop up there.
Okay. And I do want to mention that on Paul's site, if you see any book or video presentation covers for any of the presentations from any of the conferences, or if you click on Paul's link for books and videos, any books or videos that you purchase through his website, most of that goes back to Paul, and that helps to kind of fund his own personal experimental fund, because besides his company, he does have a shop over at his house. And so somebody was talking earlier about, sending money and stuff like that, which actually, if you do want to make a donation to Paul, there is a link in the right column for if you want to send any money through PayPal or whatever, and that money is just going to go into parts and different stuff like that to be able to do some experiments in his home lab. And, of course, that's the kind of stuff that's going to be shared on his website. And I guess other than that, thanks for being on the call, Paul, and for everybody else.
It was fun. Thanks for listening in, guys. Hope I helped you out.
Okay, and next time we do this, I'll just send an announcement out again, and hopefully we can do these on a regular basis.
Could I help you out?
Is Aaron there?
Yeah, this is Aaron.
Thank you.
Hey, Aaron, I need to talk to you one of these days.
Yeah, who is this?
My name is Jerry. I'm over in Denver, Colorado. I have some answers for some of the things you're working on. So I've been doing this a long time, like Paul.
Okay. What's the last 4 digits of your number?
1161.
Okay, Jerry from Denver?
Yeah.
Okay. Is that
Are we still on the air? Or?
Yes.
Yeah. Is that a mobile phone?
No. It's my lab.
Okay.
Some of the things people have been talking about, is it okay to go ahead and talk now?
Yeah, I mean, we're still recording right now. But
Okay. There's a young man, well, he's not that young, but a middle-aged man in Florida named John Depew. I don't know if you're familiar with him.
Ring a bell.
I'm not too sure.
Coral Castle Code.
Yeah. Uh-huh.
If anybody's looked at that, he's the person that I believe knows more about this than probably anybody out there today. He discovered what Leedskallen discovered.
Well, that's a big one.
Yep. Well, it's been proven. I actually built his motor for him, and, it does exactly what he says it'll do. But like you said, Paul, it's like nobody wants to see this happen just yet, or the people in power don't want to see it happen. So.
Yeah, well, if you're waiting on them to give approval, or
Yeah, well, we built the working model. I still have it. An engineer from NASA came and measured it. Hewlett-Packard came and measured it, and it's pretty incredible. But if somebody will look at his website, John knows a lot about the magnetic field. So
that's awesome.
Well, I have your phone number, so we can definitely.
Yeah, Aaron, if you want to give me a call, there's a couple more things I'd like to talk to you about. Peter knows me. He came to see me years ago.
Okay, and I've seen some videos or something online. Yeah.
Yeah, John's my business partner, basically. So.
Okay. Sure. Yeah.
Okay. All right.
Okay. Well, have a good night, everybody.
You too, and thank you guys for putting this on.
Sure. You're welcome.
Good night.
Okay, good night, everybody.
Good night.
Thanks.